In this video, we're going to start the KutaSoftware Infinite Algebra 2 free worksheet, Factors and Zeros. Now our instructions are to find all zeros. So essentially what that means, we're going to set that function equal to 0 and then solve for the variable. So let's get started with number 1. And remember that 0 times any number or quantity, let's just call that number a, equals 0. So in order for this function to equal 0, that means that either 2x minus 1 equals 0 or x minus 5 equals 0. So we're going to write each of those individual equations and then solve for x. So 2x minus 1 equals 0, and we have that x minus 5 equals 0. So for 2x minus 1, we'll add 1 to both sides to get that 2x is equal to a positive 1. And when we divide both sides by 2, we get that x is equal to 1/2. So again, if we were to plug 1/2 in for x, we would get 2 times 1/2 minus 1, and that would equal 0. And 0 times x minus 5 equals 0. Now let's look at when x minus 5 equals 0. We'll add 5 to both sides to get that x is equal to a positive 5. So when x is positive 5, we'll plug 5 in for x. 5 minus 5 is 0, and 0 times any quantity, 2x minus 1, equals 0. So our solutions in number 1 will have 1/2 and 5. And I'll write this in set notation, or you feel free to leave it as x equals 1/2 and x equals 5. Now on to number 2. If f of x is equal to 0, we're going to have to see when x minus 3 equals 0, when 3x plus 1 equals 0, and when x plus 1 equals 0. Because each of those 3 binomials will be multiplied together to equal our function. And if our function is 0, any one of them equal to 0 will make the function equal to 0. So we'll write x minus 3 equals 0, 3x plus 1 equals 0, and x plus 1 equals 0. I'll add 3 to both sides to get that x is equal to a positive 3 for the first binomial. I'll subtract 1, and then I'll have 3x equals negative 1, and then when I divide by 3, I'll get that x equals negative 1/3, and then finally, for my last equation, I'll subtract 1 from both sides to get that x is equal to a negative 1. So my solutions for number 2 are 3, negative 1/3, and negative 1. And number 3, I'm going to be seeing when 2x plus 1 equals 0, when x plus 1 equals 0, and I'll be solving for when x minus 1 equals 0. So writing each of those 3 equations, I'll start by solving that first equation, seeing when that first binomial equals 0. So I'll subtract 1 from both sides to get that 2x equals negative 1. And when I divide by 2, I'll get that x is equal to a negative 1/2. For my next equation, I'll subtract 1 from both sides to get that x is equal to a negative 1. And then finally, in my last equation, I'll add 1 to both sides to get that x is equal to a positive 1. So my solutions in number 3 are negative 1/2, negative 1, and positive 1. Moving on to number 4, even though we have an exponent now, the same rules still apply. In order for f of x to equal 0, that means that x equals 0, 5x minus 2 equals 0, or x squared plus 1 equals 0. So the first one is the easiest, x equals 0. If x is equal to 0, 0 times 5x minus 2 is 0, and then multiplying that to x squared plus 1 will equal 0. So we already have one solution. Now we'll just need to solve for when 5x minus 2 equals 0 and when x squared plus 1 equals 0. So solving for 5x minus 2, we're going to add 2 to both sides to get that 5x equals a positive 2. And when we divide by 5, we'll get that x equals 2/5. And lastly, I'm going to subtract 1 from both sides and get that x squared is equal to a negative 1. Now I'm going to take the square root of both sides. So I'll have that x is equal to the square root of negative 1. And the square root of negative 1 is our imaginary number I. So x is going to be equal to I, because I is equivalent to the square root of negative 1. However, since we're solving for when x squared plus 1 equals 0, and we're squaring that x value, so we're squaring that I, that means that I can be both positive I and negative I. Negative I squared equals negative 1, and I squared equals negative 1. So, even though I have 3 separate quantities that I set equal to 0, I'm actually going to have 4 solutions as my answer. So I'm going to have that x equals 0, 2/5, positive I, and negative I. And again, that's because I squared equals negative 1 and negative I squared equals negative 1. Let's continue on to number 5. And number 5, in order to find the zeros, I'm going to have to see when x equals 0, when x plus 2 equals 0, when x minus 2 equals 0, and when 3x squared minus 4 equals 0. So I'll have x equals 0, and then I'll see when x plus 2 equals 0, x minus 2, and 3x squared minus 4. Well, the first one, x equals 0. For the second one, I'll subtract 2 from both sides to get that x equals negative 2. For my third equation, I'll add 2 to both sides to get that x is equal to a positive 2. And for my last equation, I'll add 4 to both sides to get that 3x squared equals a positive 4. Then I'll divide both sides by 3 to get that x squared equals 4/3. And then I'll take the square root of both sides. So x will equal a positive square root of 4/3 or a negative square root of 4/3. Because remember, since we're squaring it, a negative times a negative is still a positive. So I'm going to rewrite x as positive or minus the square root of 4 over the square root of 3 in order to simplify, but I don't want a radical in the denominator. So in order to fix this, I'll just multiply by the square root of 3 over the square root of 3. So I'm multiplying by 1, so I'm not changing the value. So I'll have the square root of 4 times the square root of 3, which is the square root of 12, all over the square root of 3 times the square root of 3 will give me a positive whole number 3. So now I no longer have a radical in my denominator. However, this square root of 12 can be simplified. And remember, this is a positive square root of 12/3 or negative square root of 12/3. So looking at the square root of 12, in order to simplify that, I'll write it as the square root of 4 times 3. Since 4 is a perfect square, I can pull that out to get 2 times the square root of 3. So I'll have positive 2 times the square root of 3 all over 3, remembering to put my denominator back after I simplified the numerator, and I'll have negative 2 times the square root of 3 all over 3. And that's because a negative times a negative, or a negative squared, is a positive. Now if you got confused throughout that process when I was solving for x, I solved for x by taking the square root. But remember, you can also solve by factoring or by using the quadratic formula. So feel free to use whatever method is most comfortable for you. So now, writing each of my solutions in set notation, I have x equal to 0, x equal to negative 2, x equal to positive 2, x equal to a positive 2 times the square root of 3 over 3, and x equal to a negative 2 times the square root of 3 over 3. Those are my solutions for number 5. And again, remember when you're solving by using square roots, a positive squared equals a positive, and a negative squared equals a positive. So when solving by using square roots, don't forget to check for that negative solution. Now continuing on to number 6, I'm going to see when 2x minus 1 equals 0, when x squared plus 3 equals 0, and when 2x squared minus 5 equals 0. So writing each of those out, I'll solve the first equation, 2x minus 1 equals 0, by adding 1 to both sides to get that 2x equals 1, and then I'll just divide by 2 to get that x equals 1/2. So there's one solution. Now for my second solution, I'll subtract 3 from both sides to get that x squared is equal to a negative 3. So then I'll take the square root of both sides to get that x is equal to the square root of negative 3. So x is equal to the square root of a negative number. So I'm going to need to pull out I. So I'll have x equal to I times the square root of 3, but also negative I times the square root of 3 squared equals a negative 3. And then lastly, let's solve for this last equation. I'll have to add 5 to both sides to get that 2x squared equals a positive 5. Then I'll divide both sides by 2 to get that x squared equals 5 halves. So my next step, I'm going to take the square root of both sides. So I'll get that x is equal to a positive or negative square root of 5 halves. So I'm going to have a positive or negative square root of 5 over square root of 2 when I simplify. However, I don't want a radical in my denominator, so I'm going to multiply by the square root of 2 over the square root of 2, essentially multiplying by 1 and using that denominator as both a numerator and denominator for my number that's equivalent to 1. That way, you can see the square root of 2 times the square root of 2 equals a positive 2, so now I no longer have a radical in my denominator, and the square root of 5 times the square root of 2 equals the square root of 10. However, note that this is a positive square root of 10 or a negative square root of 10 over 2. So for my final solution, I have x equals 1/2, x equals I times the square root of 3, x equals negative I times the square root of 3, x equals a positive square root of 10 over 2, and x equals a negative square root of 10 over 2. Now let's move on to number 7. In number 7, I'll have that x is equal to 0, 2x minus 1 equals 0, x minus 1 equals 0, or x plus 1 equals 0. So writing each of those equations out, first of all, I have x equal to 0. So solving my next equation, I'll add 1 to both sides to get that 2x equals 1, and divide by 2 to get that x equals a positive 1/2. For my next equation, I'll add 1 to both sides to get that x is equal to a positive 1, and then lastly, I'll subtract 1 from both sides to get that x is equal to a negative 1. So my solutions are 0, 1/2, 1, and negative 1. If I was to plug any of those in for x, that would make the function equal to 0. And lastly, for this set of directions, number 8. For number 8, I'll have that 2x plus 5 equals 0, or x squared minus 2x minus 5 equals 0. So 2x plus 5 equals 0. I'll subtract 5 from both sides to get that 2x equals a negative 5, and then all I have to do is divide by 2 to get that x equals a negative 5 halves. Now my next equation, I'll have x squared minus 2x minus 5 equals 0. And I think one of the easier ways to solve this will be by using the quadratic function. My a value is equal to positive 1, my b value is equal to negative 2, and my c value is equal to negative 5. So I have the opposite of b, the opposite of negative 2, plus or minus the square root of negative 2 squared minus 4 times a times c all over 2 times a, 2 times 1. And again, the quadratic formula, when the quadratic is equal to 0, so when it's in the form of ax squared plus bx plus c equal to 0, I'll take each of those coefficients, a, b, and c, and my formula is the opposite of b plus or minus the quantity b squared minus 4ac all over 2a. So simplifying, the opposite of negative 2 is a positive 2, plus or minus the square root of negative 2 squared, which is 4, minus 4 times 1, which is 4, times negative 5 is negative 20, but if I'm subtracting a negative, it's the same as adding a positive 20, and that's all over 2 times 1, which is 2. So I'll have 2 plus or minus the square root of 24 all over 2. So my two separate solutions, I'll have 2 plus the square root of 24 over 2, and 2 minus the square root of 24 over 2. However, I can rewrite the square root of 24 as the square root of 4 times 6. So then I can pull out that perfect square of 4 to get 2 times the square root of 6. So I'll have 2 plus 2 times the square root of 6 over 2, and 2 minus 2 times the square root of 6 over 2. And note that in both of these, 2 over 2 is 1, so I'll have 1 plus 2 times the square root of 6 over 2 is 1 times the square root of 6, or simply the square root of 6. And in my second solution, 2 over 2 is 1, and I'm subtracting 2 times the square root of 6 over 2, which is 1 times the square root of 6, which is the square root of 6. So now I can write each of my solutions. Negative 5 halves, 1 plus the square root of 6, and 1 minus the square root of 6. So again, what I did, I set my polynomials that get multiplied together equal to 0 and solve for the variable. My first one was a linear equation, so that was fairly simple. I just had to add or subtract and then divide. However, my second one was a quadratic equation in which I used the quadratic formula in order to solve, and I got 2 plus or minus the square root of 24 over 2, and then I simplified that to get 1 plus the square root of 6 and 1 minus the square root of 6. Now let's move on to our next set of directions. In this next set of directions, we're to write a polynomial function of least degree with integral coefficients that has the given zeros. So essentially what we're doing the reverse of what we did in numbers 1 through 8. So it gives us that our zeros are 3, 2, and negative 2 for number 9. So that means that our function, f of x, equals, we need 3 to make one of the polynomials 0. And in order to do that, 3 minus 3 equals 0. So we'll have x minus 3. If we plug 3 into that, that would equal 0. And then for 2, 2 minus 2 equals 0. So x minus 2 is our other polynomial. And then finally, negative 2 plus 2 equals 0. So we'll have x plus 2. Now we're just going to multiply each of these together in order to write our polynomial of least degree with integral coefficients. So I'll start with my last two. So I'll multiply x to x, x to 2, negative 2 to x, and negative 2 to 2. So I'll have f of x equal to x minus 3, and then x times x is x squared, x times 2 is plus 2x, negative 2 times x is plus negative 2x, and then negative 2 times 2 is a negative 4. Now note 2x plus negative 2x is equal to 0. Hence, why I multiplied x minus 2 to x plus 2 as opposed to multiplying it by x minus 3. Because if you remember, this is in the form of a minus b and a plus b, which equals a squared minus b squared. So now I'll multiply x to x squared, x to negative 4, negative 3 to x squared, and negative 3 to negative 4. So x times x squared, my function, will equal x cubed, and then x times negative 4 will be plus negative 4x, and then negative 3 times x squared will be plus negative 3x squared, and then negative 3 times negative 4 will be plus a positive 12. Now I'm going to rewrite this in order of degree. So I'll start with my x cubed, and then go to my x squared, which is plus a negative 3x squared, or minus 3x squared, and then I'll subtract 4x to the first, or simply 4x, and then add 12. So my function in number 9 with the zeros of 3, 2, and negative 1 is x cubed minus 3x squared minus 4x plus 12. Moving on to number 10, I have 4 separate zeros. So I'll have that x minus 3, since 3 minus 3 equals 0, x minus 1, since 1 minus 1 equals 0, x plus a positive 2, since negative 2 plus 2 equals 0, and x plus a positive 4, since negative 4 plus 4 equals 0. I'll FOIL my first two terms, and I'll also FOIL my last two terms. So I'll have the function of x equal to x times x, which is x squared, plus x times negative 1, which is negative 1x, plus negative 3 times x, which is negative 3x, plus negative 3 times negative 1, which is a positive 3. So that will get multiplied to x plus 2 times x minus 4, which x times x is x squared plus x times 4 is 4x plus 2 times x is 2x plus 2 times 4, which is 8. Now, before I multiply these together, I'm going to simplify. So I'll have f of x equal to x squared plus negative 1x plus negative 3x is a negative 4x, and then I'll add that to 3, and that will get multiplied to x squared plus 4x plus 2x is 6x plus 8. Now I'm going to multiply each of these terms together. So starting with this x squared, it will get multiplied to x squared, 6x, and 8. So x squared times x squared is x to the 4th plus x squared times 6x, which is 6x cubed, plus x squared times 8, which is 8x squared. Now I'm going to take care of my negative 4x. Negative 4x times x squared is negative 4x cubed. And then negative 4x times 6x is a negative 24x squared. And then negative 4x 8 will be a negative 32x. And then lastly, my 3. 3 times x squared is 3x squared. 3 times 6x is plus 18x. And then 3 times 8 is plus 24. Now I'm going to simplify by combining my like terms. So I have 6x cubed and negative 4x cubed that can be combined. I also have x squared, negative 24x squared, and 3x squared that can be combined. And I have a negative 32x and a positive 18x that can be combined. So f of x equals x to the 4th plus, now I'll take care of my x cubed values, 6x cubed minus 4x cubed is a positive 2x cubed. Now I'll take care of my x squared values, which 8x squared, I'll add that to 3x squared to get 11x squared. However, that's going to be added to a negative 24x squared, so I'll get minus 13x squared, since 8x squared minus 24x squared plus 3x squared equals a negative 13x squared. And then I'll take care of my x to the first values, which is negative 32x plus 18x, which is a negative 14x or minus 14x. And then lastly, I'll add 24. So my solution, and number 10, is the function of x equals x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24. That's the function of least degree when the zeros are 3, 1, negative 2, and negative 4. Continuing on to number 11. In number 11, my function is going to be equal to 0 when x is equal to 5, so that's x minus 5, since 5 minus 5 is equal to 0, when x equals negative 1, so that's x plus 1, since negative 1 plus 1 equals 0, and when x is equal to 0, so multiplying that by x. So in order to solve, I'm going to FOIL my first two terms, and then multiply that by x. So I'll multiply x to x to 1, negative 5 to x, and then negative 5 to positive 1. So I'll have x squared plus x times 1 plus 1x plus negative 5 times x, negative 5x, plus negative 5 times 1, which is negative 5, and that will all get multiplied by x. So I'm going to simplify and then multiply by x. So I'll get x squared, 1x plus negative 5x is the same as negative 4x, so I can simply subtract 4x, and then I'm going to be subtracting 5. That will get multiplied to x, so now I'll distribute my x. So the function of x equals x times x squared, which is x cubed, minus 4x times x, which is 4x squared, minus 5 times x, which is 5x. So again, my function is equal to x cubed minus 4x squared minus 5x. Now for number 12, my x is equal to negative 3. That will make my function equal to 0. So I'll have x plus 3 because negative 3 plus 3 equals 0. Then I'll have x equal to negative 1/3. So if x is equal to negative 1/3, if I multiply both sides by positive 3, I'll get that 3x is equal to negative 1. And then I'll simply add 1 to both sides to get that 3x plus 1 equals 0. So when x is equal to negative 1/3, if I plug that in, I'll get 3 times negative 1/3 plus 1, and that will equal 0. So my other quantity for when x equals negative 1/3, that would be 3x plus 1. And to double check, plug negative 1/3 in, and you will indeed get 0. And then lastly, I have x equal to 5, so I'm going to have x minus 5, because if x equals 5, 5 minus 5 equals 0. Now I'm going to multiply my first two terms together in order to simplify. So I'll have 5x equal to x times 3x, which is 3x squared, plus x times 1 plus 1x, plus 3 times 3x, which is 9x, plus 3 times 1, which is 3. And that will get multiplied to x minus 5. So I'm going to simplify this first polynomial before I multiply by x minus 5. So I'll have 3x squared plus 1x plus 9x is 10x plus 3, and that's multiplied by x minus 5. So now I'll multiply x to 3x squared, 10x, and 3. So I'll have 3x cubed plus 10x squared plus 3x. And next, I'll multiply negative 5 to each of those. So negative 5 times 3x squared is subtracting 15x squared. Negative 5 times 10x will be subtracting 50x. And then negative 5 times 3 will be subtracting 15. So now I'll combine my like terms and simplify. I'll combine 10x squared and 15x squared, and I'll combine 3x and 50x. So I'll have my function of x equal to 3x cubed, and then 10x squared minus 15x squared is a negative 5x squared, so subtracting 5x squared, and then 3x minus 50x is going to be a negative 47x, so subtracting 47x, and then lastly subtracting 15. My function of x equals 3x cubed minus 5x squared minus 47x minus 15. That's my function in which x is negative 3, negative 1/3, and 5 as the zeros. Continuing on to number 13, let's start by looking at when the 0 is 5/3. So x is equal to 5/3, that will be 1, 0. However, if we plug 5/3 in for x, what would that equation be? Well, let's start by multiplying by the denominator. So we'll have 3x equal to a positive 5. And then all we need to do is subtract 5 to get that 3x minus 5 equals 0. So if we were to plug 5/3 in for x, that would equal 0. 3 times 5/3 minus 5 would equal 0. So 3x minus 5 is one factor of the function. Next, if x is positive 1, then we'd have to subtract 1 to get it to equal to 0, so x minus 1, and then if x is negative 1, x plus 1 will equal 0. So first I'm going to start by multiplying x minus 1 to x plus 1. So I'll have f of x equal to 3x minus 5, and then x times x is x squared, plus x times 1 is 1x, and then negative 1 times x is minus 1x, plus negative 1 times 1 is negative 1. So you can see that 1x and negative 1x will cancel out. 1x minus 1x is 0. So I'm going to take 3x, multiply it by x squared, then multiply it to negative 1, and then take 5, multiply that to x squared, and multiply that to negative 1. But remember that's 5 is subtracted. So I'll have f of x equal to 3x times x squared, which is 3x cubed, and then 3x times negative 1, so I'm subtracting 3x, and then negative 5 times x squared, so I'll be subtracting 5x squared, and then negative 5 times negative 1 is positive 5, so I'll be adding 5. So I'm going to rearrange this so that my degrees are in order. So I'll have f of x equal to 3x cubed minus 5x squared minus 3x plus 5. And that's my solution and number 13. Lastly, for this set of directions, number 14. I'll have f of x equal to x minus 2, since when x is equal to 2, the function is equal to 0, and 2 minus 2 equals 0. Then 5/3, but remember we just had this in the previous problem. Remember that was 3x minus 5, because if we were to put in a positive 5/3 for x, 5/3 times 3 is a positive 5, and 5 minus 5 is 0. And then lastly, if x is equal to negative 5, x plus 5 will equal 0. So I'll start by multiplying my first two binomials together. So f of x equals x times 3x, which is 3x squared, and then x times negative 5 is plus negative 5x or minus 5x, and then negative 2 times 3x is negative 6x, so subtracting 6x, and then negative 2 times negative 5 will be adding a positive 10, and that will get multiplied to x plus 5. So simplifying, f of x equals 3x squared minus 11x, since negative 5x minus 6x is negative 11x. As opposed to adding, we'll be subtracting that 11x, and then we're adding 10, and that will get multiplied to x plus 5. So now I'm going to take the x, multiply it to 3x squared, 11x, and 10, and then I'm going to do the same for 5. Multiply it to 3x squared, 11x, and 10. So I'll have f of x equal to 3x cubed, 3x squared times x, minus 11x squared, plus 10x, taking care of multiplying x to each of the terms. Now let's look at multiplying 5 to each of the terms. 5 times 3x squared is 15x squared. 5 times 11x is 55x, and that's going to be subtracted. And then 5 times 10 is 50. Now I'm going to combine my like terms. 11x squared, 15x squared, and 10x and 55x. So I'll have my function of x equal to 3x cubed, and then negative 11x squared plus 15x squared equals a positive 4x squared. So plus 4x squared, and then 10x minus 55x is a negative 45x, so minus 45x, and then I'm adding 50. So my final solution for this set of directions is the function of x equals 3x cubed plus 4x squared minus 45x plus 50. Let's continue on to the next set of directions. However, before I move on to that, now's a good time to click that like button and subscribe to my channel if you haven't done so already. All likes and subscriptions are greatly appreciated. Now, our next set of directions say to find all zeros by factoring each function. Now, before we jump into this, I'm going to quickly go over a couple of the special case polynomials, which these formulas will be helpful when finding the zeros in the next 6 problems. So remember that we have a plus b squared. That's going to be equal to a squared plus 2ab plus b squared. We also have a minus b squared, which is equal to a squared minus 2ab plus b squared. Next, as far as with a degree of 2, there's a squared minus b squared, which is equal to a plus b times a minus b. And then the sum of cubes, so if we have a to the third plus b to the third, that formula is a plus b times a squared minus ab plus b squared. And for the difference of cubes, a cubed minus b cubed, we're just going to switch a few signs. So as opposed to a plus b, we're going to have a minus b. And as opposed to a squared minus ab, we're going to have a squared plus ab, and then we're still adding that b squared. So I recommend writing these formulas down so that you can refer back to them when we get to a problem that utilizes one of them. However, looking at number 15, each of the terms has x in common, so we'll be able to pull out x. So we'll rewrite f of x as x times x squared minus 2x plus 1. So now we're going to be factoring x squared minus 2x plus 1. So f of x equals x times, let's see, what multiplies to give us 1 and adds to give us a negative 2. Well, that's going to be negative 1. So we'll have x minus 1 times x minus 1. And again, if you were to multiply x minus 1 times x minus 1, you would get x squared minus 2x plus 1. Because negative 1 times negative 1 is a positive 1, and negative 1 plus negative 1 is a negative 2. Multiplies to give us c and adds to give us b. Now I'm going to simplify this even further, writing f of x as x times x minus 1 squared. So my factors are when x equals 0 and when x minus 1 equals 0. And x equals 0, my solution is 0, and for x minus 1 equal to 0, I'll have x minus 1, and I'll just need to add 1 to both sides to get that x is equal to a positive 1. So my other solution is 1. However, since that's squared, my 0 of 1 occurs twice. So therefore I'm going to say 1 with a multitude of 2. So 0 and 1 are my solutions, and 1 occurs twice. Let's continue on to number 16. In number 16, I'm going to rewrite x cubed plus 8, and I'm going to write it as f of x equals x cubed plus 2 cubed. That way, it will look like one of my formulas. X cubed plus 2 cubed, I can then factor as a plus b times a squared minus ab plus b squared. And that's because 2 cubed is equal to 8. So my a value is x, and my b value is 2. So my a in this case is x, and my b is 2. So for a plus b, I'll have x plus 2, and then a squared minus ab plus b squared. I'll have x squared, so a squared minus a times b, so that's minus 2x, or minus x times 2, plus b squared, so plus 2 squared, which I'll write as plus 4. Now zooming back in, now in order to find the zeros, we need to see when x plus 2 is equal to 0 and when x squared minus 2x plus 4 is equal to 0. And there's no numbers that multiply to give me a positive 4 and add to give me a negative 2, so I'm going to be using the quadratic formula in order to find the zeros of this quadratic. However, for x plus 2, I'll just have x plus 2 equal to 0, subtract 2 from both sides to get x equal to negative 2. So one of my zeros I know is negative 2. Now let's look at that quadratic. So my values a, b, and c, I'll have positive 1, negative 2, and positive 4. So for the opposite of b, I'll have the opposite of negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, 4 times 1, times c, which is times 4, all over 2 times a, 2 times 1. Simplifying this, the opposite of negative 2 is a positive 2, so I'll have 2 plus or minus the square root of negative 2 squared, which is 4, minus 4 times 4, which is 16, all over 2. So 2 plus or minus the square root of 4 minus 16 will be 2 plus or minus the square root of a negative 12, all over 2. Now because this 12 is negative and it's inside that square root, I'm going to simplify by pulling out an I. So I'm going to have 2 plus or minus I times the square root of positive 12. However, I know that a perfect square is a multiple of 12, and that perfect square is 4. So 4 times 3 is equal to 12. So in my numerator, I'll have 2 plus or minus I times the square root of 4 times 3 all over 2. And remember, this I came from the negative 1 that was multiplied to 12. So I just pulled that out. The square root of negative 1 is I. So now I'll simplify to 2 plus or minus I times 2, or 2 times I, pulling out that perfect square of 4. 2 squared is equal to 4, so the square root of 4 is 2, times the square root of 3 all over 2. Now note that in the numerator, both my terms are divisible by 2. 2 goes into 2 once, and 2 goes into 2 once again. So I'll write this as 1 plus or minus 1 times I times the square root of 3, which is I times the square root of 3. Now from that, I will have two separate solutions. I'll have 1 plus I times the square root of 3, or 1 minus I times the square root of 3, because this is plus or minus. However, that is only the zeros for this quadratic. So in total, my entire solution are the zeros for this polynomial and the zeros for this polynomial. So my solution is negative 2, 1 plus I times the square root of 3, and 1 minus I times the square root of 3. Since I have to take into account that I'm adding I times the square root of 3 for one zero and I'm subtracting it for another 0. Therefore, negative 2, 1 plus I times the square root of 3, and 1 minus I times the square root of 3 are my three solutions for number 16. Now, moving on, it looks a little more complicated, but don't worry, I'll walk through the steps with you. What I'm going to do, I'm going to be substituting in a value for x squared, because when I rewrite f of x in terms of x squared, I'll get x squared squared, since x squared squared is x to the fourth, then minus x squared minus 30. So if I set x squared equal to some value a, I'll write my function of x as a squared minus a minus 30. Now you can see that I have a quadratic, and I can factor this quadratic because I know there's two numbers that will multiply to give me negative 30 and add to give me negative 1. So the factors of 30 that will work are 5 and 6. And since this is a negative 30 and I need negative 1, I'll be using negative 6. So I'll have a plus 5 and a minus 6. So that means that my zeros occur when a plus 5 equals 0 and when a minus 6 equals 0. So a plus 5 equals 0 occurs when a equals negative 5, and a minus 6 equals 0 occurs when a equals a positive 6. However, those are not my zeros for my original function. Remember, a was equal to x squared, so that means that x squared equals negative 5 and x squared equals 6 are my zeros. But I have a little bit more work to do for them before I get what x is equal to. So let's first look at x squared equal to negative 5. If x squared is equal to negative 5, looking at this equation, then I'll take the square root of both sides to get that x is equal to the square root of negative 5. However, the square root of negative 5 I will rewrite as I times the square root of 5, or negative I times the square root of 5. Because remember, this quantity squared equals negative 5, and negative I times the square root of 5 squared also equals negative 5. Because when I'm squaring that negative I times negative I equals I squared, as well as I times I. That also equals I squared. So since I already have I times the square root of 5 and negative I times the square root of 5, I'll move on to see when x squared equals 6. X squared equals 6, I'll take the square root of both sides to get that x is equal to the square root of 6, and x is equal to negative square root of 6, or the opposite of the square root of 6. So then I have two more solutions. So in total, the zeros for number 17 are the square root of 6, negative square root of 6, I times the square root of 5, and negative I times the square root of 5. Let's continue on to number 18. In number 18, we're going to be using the same concept. So we're going to write f of x as x squared squared, that's equal to x to the fourth, plus x squared minus 12. So we're going to have a equal x squared. So we'll write this as a squared plus a minus 12. So now I need to see what two numbers multiply to give me negative 12, but add to give me a positive 1, since it's 1 times a, or plus 1a. And those numbers, looking at the factors of 12, I know the numbers that will work will be 3 and 4. Now we just have to decide which one's negative, which will be a negative 3, because negative 3 plus 4 equals a positive 1. So we'll write this as a minus 3 and a plus 4. So that means for a minus 3 equal to 0, or a plus 4 equal to 0, I'll have a as a positive 3 or a as a negative 4. But note that those are not my zeros for the function itself. To solve for the zeros of my function, I need to plug back in x squared for a. So I'll have x squared equal to a positive 3 and x squared equal to a negative 4. So let's first look at when x squared equals a positive 3. X squared equals 3. I'll take the square root of both sides to get that x is equal to the square root of 3, and that also entails that x is equal to the negative square root of 3. So now let's look at when x squared equals negative 4. Taking the square root of both sides, I'll get that x is equal to I times the square root of 4 and negative I times the square root of 4, since both of those quantities squared equals a negative 4. However, I can simplify each of these down, because the square root of 4 is equal to 2. So I'll have that x equals 2i and x equals negative 2i, since the square root of 4 is positive 2. So my solutions for number 18 are 2i, negative 2i, the square root of 3, and the opposite or negative square root of 3. So again, those solutions were the square root of 3, negative square root of 3, 2i, and negative 2i. Continuing on to number 19, this is where, again, those formulas at the beginning of this video will be very helpful. What I'm going to do, I'm going to rewrite f of x as x cubed squared minus 8 squared. So you can see that I have a squared minus b squared. So my a value is x cubed and my b value is a positive 8. So for a squared minus b squared, I'll get, looking back up at our formula, a squared minus b squared is a plus b times a minus b. So for number 19, it's a plus b times a minus b, which, if a is x cubed and b is 8, we will have x cubed plus 8 times x cubed minus 8. So now, over here, I'm just going to rewrite our function as x cubed plus 8 times x cubed minus 8. Now we can go even further with this, because x cubed plus 8 and x cubed minus 8 can be written as the sum of cubes and the difference of cubes. So we can rewrite x cubed plus 8 and x cubed minus 8 as x cubed plus 2 cubed, since 2 cubed is 8, and x cubed minus 2 cubed, since 2 cubed, again, is 8. Now, going back up to our formulas, we can use the bottom two. So for a cubed plus b cubed, we have a plus b times a squared minus ab plus b squared. And for a cubed minus b cubed, we have a minus b times a squared plus ab plus b squared. So let's utilize those formulas for number 19. So working out the sum of cubes, our function is going to be equal to, remember for the sum of cubes it's a plus b, so that's x plus 2, and then we're multiplying that by a squared minus ab plus b squared. So that's x squared minus a times b, so that's 2 times x, plus b squared, which is 2 squared, which I'll write as 4. Now, let's work through the difference of cubes. So this is all multiplied by the difference of cubes, which a cubed minus b cubed was a minus b, so x minus 2 times a squared plus ab plus b squared. So that's x squared plus 2x plus 4. So we're not quite done yet, because remember we're factoring to find the zeros. So we have to figure out when x plus 2 equals 0, when x minus 2 equals 0, when x squared minus 2x plus 4 equals 0, and when x squared plus 2x plus 4 equals 0. So x plus 2 equals 0 occurs when x is equal to negative 2, since negative 2 plus 2 equals 0. X minus 2 equals 0 occurs when x is equal to a positive 2. So we have x equal to negative 2 and x equal to 2, since 2 minus 2 also equals 0. Now, zooming out a bit, I'm going to first work through when x squared minus 2x plus 4 equals 0, and I'm going to do that using the quadratic. However, if you note, the only thing different from x squared minus 2x plus 4 and x squared plus 2x plus 4 is our b values. One is positive and the other is negative, and all the other values are the same. So remembering our quadratic formula, it's the opposite of b plus or minus b squared minus 4ac all over 2a. So let me write that out really quickly. The opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So when this b gets squared, regardless of whether b is positive or negative, this value within the square root doesn't change. So I'm only going to do the quadratic formula once for both equations because all I have to do is change the sign to get the other solutions. Let me work through the steps and show you what I mean. So let's work through the steps for x squared minus 2x plus 4. So we have the opposite of b, so it's going to be the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times a, 4 times 1 times 4, all over 2 times a, 2 times 1. So that's the opposite of negative 2, which is a positive 2, plus or minus the square root negative 2 squared, which is 4, although remember if this was a positive 2 squared, that would be a positive 4, which we get regardless of whether b is negative or positive, and then we'll subtract 4 times 4, which is 16, and that's all over 2. So that will give us 2 plus or minus the square root of 4 minus 16, which is negative 12, all over 2, which I'll simplify to 2 plus or minus I times the square root 4 times 3, all over 2, to a previous problem we've done, and I rewrote 12 as 4 times 3 so that I can pull out that perfect square and have 2i. So continuing my work down below, I'll have 2 plus or minus 2i times the square root of 3 all over 2, which 2 is divisible by 2, so both my terms are divisible by 2, so I can simplify this as 1 plus or minus I times the square root of 3. And note that this should be familiar because it is very similar to number 16, which we've already completed. So if you're confused on any of the steps, refer back to number 16 when simplifying if you got lost. So we have 1 plus I times the square root of 3, or 1 minus I times the square root of 3, as two more answers. However, remember that the b was negative in this case, and we need to find the factors for when b is positive. So all we're going to do is change the sign of b, which is that positive 1. So if we were to work out the quadratic for the second and the last polynomial, we'll have negative 1 plus or minus I times the square root of 3, because the b in that case was negative, but remember when it's getting squared, the negative or positive does not matter. However, outside, at the very beginning, it does. The opposite of a negative 2 was a positive 2, but the opposite of a positive 2, that would have been then a negative 2, which would then simplify down to a negative 1. So negative 1 plus or minus I times the square root of 3 gives us the two solutions for our last polynomial. So now that we have solutions for each of the polynomials, the first, second, third, and fourth that multiply together to give us our function, I now have the zeros. So for number 19, our solutions are negative 2, 1 plus I times the square root of 3, 1 minus I times the square root of 3, positive 2, negative 1 plus I times the square root of 3, and negative 1 minus I times the square root of 3. So you can see that we have 6 solutions for number 19. 1 for the x plus 2 polynomial, 2 for x squared minus 2x plus 4, 1 for x minus 2, and then 2 for x squared plus 2x plus 4. Now let's continue on to our last and final problem, number 20. If you haven't done so before number 20, feel free to like this video and subscribe to my channel. All likes and subscriptions, like I said previously, are greatly appreciated, and just let me know that you're finding these videos useful. Now for number 20, I'll give you a hint. We're going to rewrite f of x so it looks like one of the formulas that we wrote down as soon as we started this section. I'm going to write this as x cubed squared plus 2 times x cubed times 1 plus 1 squared. So multiplying by 1 does not change the value of that middle term 2x cubed, and x cubed squared is equal to x to the 6th, and 1 squared is also equal to 1. But note that I put this in the form of a squared plus 2ab plus b squared, which we know is a plus b times a plus b. So in this case, our a value I wrote as x cubed, and the b value I wrote as 1. So I'm going to rewrite our function a plus b times a plus b. So that's x cubed plus 1 times x cubed plus 1. So x cubed plus 1 times x cubed plus 1 can also be written as x cubed plus 1 squared. However, if we look closer at this, x cubed plus 1 squared, I'm going to rewrite as x cubed plus 1 cubed squared, since 1 cubed is still equivalent to 1. So now I'm going to be able to factor x cubed plus 1 cubed as the sum of cubes, which, if you remember the formula for the sum of cubes, that's a plus b times a squared minus ab plus b squared. So I'll have x plus 1, since my new a and b values will be x and 1. So that's x plus 1 times x squared minus x plus 1. And remember, this is all squared. So the zeros of each of those occur twice. So just remember that when we find the zeros, those zeros are occurring twice for the zeros of these individual polynomials. So x plus 1 equal to 0 and x squared minus x plus 1 equal to 0. We're going to solve for those. So x plus 1 equals 0, subtracting 1 from both sides, when x equals negative 1. So negative 1 is one of the solutions, and remember that negative 1 occurs twice. Now let's look at when x squared minus x plus 1 equals 0. And I'm going to do that by using the quadratic formula. So my a value is 1, my b value is negative 1, and my c value is a positive 1. So I'll have the opposite of b, the opposite of negative 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, so 4 times 1 times 1, all over 2 times 1. Simplifying, the opposite of negative 1 is a positive 1, and I'll have plus or minus the square root of 1 minus 4, since negative 1 squared is a positive 1, and we're subtracting 4, so that's the square root of negative 3 all over 2. And I can rewrite the square root of negative 3 as I times the square root of 3, since the square root of negative 1 is I, and the square root of negative 1 times the square root of 3 will be I times the square root of 3, and that's 1 plus or minus I times the square root of 3 all over 2. And that cannot be simplified any further, but remember, that gives me two separate solutions. So for number 20, our first solution was negative 1, and that occurred twice. So negative 1 with a multitude of 2, since negative 1 occurred twice. Our next solution, I'll write 1 plus I times the square root of 3 over 2, and that also occurred twice. And remember, these multitudes of 2 are for when I would solve for x cubed plus 1, and then again solve for x cubed plus 1. However, since I wrote it as a squared, I'm not going to go through and individually solve for those zeros twice. I just wrote it as squared, and I'm noting that they occur twice. So then, lastly, I have 1 minus I times the square root of 3 over 2, and again, that occurs twice. So my solutions for the last problem of number 20 is -1, and that occurs twice, 1 plus I times the square root of 3 over 2, and that occurs twice, and 1 minus I times the square root of 3 over 2, and that again occurs twice. Each of those zeros is repeated. And with that, I wrap up this worksheet. If you have any questions, feel free to leave them in the comments below, and I'll get back to you as soon as I can. And if you haven't done so already, here's a friendly reminder to like, subscribe, and share.